Have you ever wondered how AI is starting to see, hear, and understand the world more like we do? It's not just about crunching text or analyzing pixels anymore. We're entering the era of multimodal AI, and it's about to change everything. So, what exactly is multimodal AI? In simple terms, it's AI that can understand and process information from different sources or modalities all at once. Think about how you experience the world. You see a dog, you hear it bark, you feel its fur, and you might say, "What a cute puppy." You're seamlessly combining sight, sound, touch, and language. Multimodal AI aims to give machines that same holistic understanding, bridging the gap between their cold, hard logic and our rich, sensory perception. Early AI was largely unimodal. It could either be a master at understanding text, like a search engine, or brilliant at recognizing images, but it couldn't do both at the same time. This was a huge limitation. An image recognition model could see a picture of a birthday party, but wouldn't understand the text on the happy birthday banner. A text model could read a recipe, but couldn't see what the final dish should look like. Multimodal AI breaks down these silos. By combining different data types, it creates a much richer, more contextual understanding of the world, just like we do. To build these systems, we need to work with various modalities. The most common are vision, which involves processing pixels in images and videos, and language, which deals with words, grammar, and context. Then there's audio, which includes everything from human speech to environmental sounds, analyzed as waveforms and frequencies. But it doesn't stop there. Researchers are also exploring haptic data for touch, olfactory data for smell, and even sensor data like LiDAR and radar used in self-driving cars. The biggest challenge: these data types are fundamentally different. An image is a grid of pixels, text is a sequence of words, and audio is a wave. The trick is to teach the AI to find the connections between them, to align a word with an object in a picture, or a sound with an action in a video. So how do engineers pull this off? It all starts with something called representation learning. The goal is to convert all these different data types into a common mathematical language, or embedding space. Think of it like a universal translator. Models like CLIP, for example, learn to map both images and their text descriptions to the same conceptual point in this space. So the image of a cat and the words "a photo of a cat" end up very close together. Once the data is in a common format, we need to fuse it together. There are a few ways to do this. Early fusion combines the raw data right at the beginning. Late fusion runs separate models for each modality and then combines their final predictions. But the most powerful method is intermediate fusion, often using something called a cross-attention mechanism, which is a key feature of modern transformer architectures. Transformers, which revolutionized text with models like BERT and Vision with Vision Transformers, are perfect for this. They can pay attention to different parts of the input, allowing them to dynamically weigh the importance of a word from the text, a patch from an image, and a segment of audio, and figure out how they all relate to each other. This powerful technology enables some truly mind-blowing applications that you're probably already familiar with. Take image captioning, where an AI generates a sentence describing a picture. Or its opposite, text-to-image generation, where models like DALL-E and Midjourney create stunning artwork from a simple text prompt. We also have visual question answering, where you can ask an AI question about an image, like how many people are in this photo. And it's not just about images. Multimodal sentiment analysis can determine how someone is feeling by analyzing their words, tone of voice, and facial expressions all at once. In video understanding, I can recognize complex activities, like identifying different plays in a sports game. The real-world impact is already massive and it's growing every day. Autonomous systems are a prime example. A self-driving car doesn't just rely on cameras. It fuses data from LiDAR, radar, GPS, and high-definition maps to build a complete 360-degree understanding of its environment, allowing it to navigate safely. In healthcare, doctors are starting to use AI that can analyze medical images like X-rays, patient history from text records, and even genetic data to make more accurate diagnoses. In robotics, multimodal perception allows a robot to not only see an object, but also understand verbal commands about it, like pick up the red ball. It's even transforming creative industries, with AI assisting in composing music, editing videos, and creating entirely new forms of art. But the journey is far from over. We still face significant challenges. One of the biggest is data. Creating large, high-quality datasets where different modalities are perfectly aligned, like a video with a precise transcript and annotations of every sound and action, is incredibly expensive and time-consuming. These models are also computationally massive, requiring huge amounts of processing power to train and run, which raises environmental and accessibility concerns. Then there's the black box problem. It's often difficult to understand exactly how these complex models arrive at a decision. Making AI more interpretable and explainable is a critical area of research. And of course, we must navigate the ethical minefield. How do we prevent biases in the training data from being amplified? How do we protect user privacy? And how do we combat the malicious use of this technology, such as the creation of convincing deepfakes? Looking ahead, the ultimate goal is to move towards a more generalized multimodal intelligence, an AI that can learn and reason about the world with the flexibility and nuance of a human. We're on a path to creating AI that doesn't just process data, but truly perceives and understands our world in all its rich, multi-sensory glory. It's an incredibly exciting, interdisciplinary field that brings together computer vision, natural language processing, speech recognition, and more. The future isn't just about AI that is smarter, but AI that is wiser, more perceptive, and more aligned with the way we experience reality. Thanks for watching. If you found this deep dive into multimodal AI fascinating, don't forget to like, subscribe, and hit that notification bell for more content on the future of technology. See you in the next one.